Disclaimer, disclaimer, disclaimer. Stop whatever you are doing. Unless you are operating an automobile, performing life-saving surgery, or in the midst of childbirth, or otherwise pushing your way through another busy day on planet Earth, in which case, go ahead and carry on. But if we have caught you at a moment in which there are no other distractions, no other media consuming your thoughts or duties dividing your attention, listen up and listen tight. You are needed elsewhere. For the world is at war, and you are being enlisted into active duty. It is up to you, yes, you, and only you, for the enemy is within. Only you can prevent the complacent, unquestioning thoughts within your skull from slipping out and stifling your scientist within. The enemy is better funded, better equipped, and knows your mental terrain better than you. It thrives in every routine moment of media consumption, an unquestioned answer given by experts with confident and conflicted interests. And the enemy has been plotting against you for longer than you were aware that your thoughts could be conspired against. This is no time to rest upon the shoulders of giants and expect that the hard work of ponderers past will be enough to lift our society to the full freedom of our mental potential. It's up to you to break the chains that bind your mind to the push and pull of day-to-day intellectual incarceration and step boldly into the air of liberated thought here on This Week in Science. Coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science, Kirsten.
Good science. That was quite a lungful. You held,
I can do better.
You
Want me to
held on to
retake it?
No. That was good.
I could fill a show with that.
Well, we have lots of science for the show. We don't need to be yelling about it. We could yell it to the rooftops. We got science. We got science. Yelling is fun. All right, everybody. We have a great show ahead. It's almost the holidays. Week or so away. And you know what that means? Twistmas is coming soon. I know. We love Twistmas. But in the meantime, we have science news. I brought stories about space, robots, and measuring our magnetic field. What did you bring?
I've got ecstasy, good feelings, and why you should start eating almonds.
Yeah? Not drinking them?
Drinking almonds? What?
Never mind.
What?
What?
Oh, and a lost city.
You found a lost city?
Of Neanderthals?
Ooh, that sounds exciting. I am excited about this story.
Ooh.
And more? No.
This one right here, though. This is probably the one I'll do first.
Oh, dear. Oh, dear.
Updated periodic table.
Oh, yes.
Yeah.
Okay.
That's pretty awesome.
Periodic table. We look at that and we think, hey, this is a periodic table. It's not going to change. Maybe we'll add some elements to it.
On a table.
Yeah.
It was written on a table. There's boxes. It's defined. People memorize this. It must never change.
Never.
And it happened.
It happened. I love it.
And they didn't just add a box. They're taking the boxes that were already there and recombobulating some stuff.
All right. Well, in the meantime, before we get to the atomic recombobulation, the LHC can't kill us with black holes.
Or confirm string theory. Woo!
Or confirm string theory. Right. There's that as well. But it can't kill us. This is great. This is great news. Everyone's like, oh, the LHC, it's going to kill us. There are all these mini black holes that are going to be formed. And, and then some people were afraid of the mini black holes. And what if the mini black holes become bigger black holes? Because what do black holes do but just suck in matter? And what if the whole Earth just disappeared in a black hole because we decided to smash some atoms together? Well, A lot of people said, "Oh no, the mini black holes, they won't have that great of an energy. They'll blink into and out of existence. It'll not, we expect they'll be found, but this not going to be a big deal. Don't worry, don't worry, don't worry." There were all these, pats on the back and everything. Well, we didn't even need to worry at all. At all. They have completed a search for these microscopic black holes produced in high energy proton-proton collisions, and found nothing. Blank, zip, zero, zilch, no black holes, no little tiny black holes, no bigger black holes, no teeny, 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 tiny black holes. No, they've excluded up to a black hole mass of 3.5 to 4.5 trillion electron volts, as 10 to the 12th electron volts in tera electron volts, in a variety of theoretical models. Now, they're predicted to exist in by string theory. And so the fact that they haven't been found kind of puts some question into the idea of string theory.
No, Kirsten, it doesn't question string theory in any way, shape, or form. It just means we need a much, much, much bigger collider. One like 10 times the size of the one that's there. And then we might be able to find it.
Okay. So we just need to smash things together harder. And then we'll get to it. And then we'll confirm string theory.
Just because the test didn't match up with our theory doesn't mean our theory's wrong. It means that all of the experiments are wrong. The experimentation was incorrect. We need more power, more equipment, a more finely tuned.
I've got to have more power.
I've heard this before. Oh yeah, That's what they said over at LIGO.
All right. Well, the string theory side of it, the fact that they haven't found many black holes doesn't completely toss string theory under the bus. This is just one experiment out of many that was suggested to start to confirm the ideas that are hypothesized by string theory. This one just didn't pan out. So, there are other experiments that we're going to be looking forward to in the future. This is just one of them. We're going to be, hoping that we'll find some more evidence in the future. What does this say here? So, microscopic black holes are predicted to exist in some theoretical models that attempt to unify general relativity and quantum mechanics by postulating the existence of extra curled up dimensions in addition to the 3 familiar spatial dimensions. At the high energies of the Large Hadron Collider, such theories predict that particles may collide closely enough to be sensitive to these postulated extra dimensions. In such a case, the colliding particles could interact gravitationally with strengths similar to those of the other 3 fundamental forces, the electromagnetic, weak, and strong interactions. The 2 colliding particles might then form a microscopic black hole, and that black hole would evaporate, leaving a spray of some subatomic particles of normal matter that would then be detected and observed by the CMS experiment at the LHC. They looked for it. No evidence.
And the underpinning assumption in that is that gravity is a force.
Not necessarily that it's a force. I mean, gravity is measurable. It's something that definitely has an effect. So I don't know necessarily that it
It may not be anything that's actually measurable or have an effect, though. It could, it could be the result of the interactions on a quantum level that are just because of the interactions of very, very tiny things that we don't see, and not actually be force that's measurable other than it's the relative difference in the way that matter is moving in one direction and another. Mm-hmm. But it's not, right. I mean, it's one of the things that Verlind is suggested. That's the sort of emergent idea, is that what we see as gravity might be a construct of space and not a force. And the assumption that it's a force, because we have never seen it as a force. We've never been able to measure gravity as a force separate from, interactions of anything else. Right. No gravitons have been discovered. So Yeah, I'm calling this thus far. I'm calling this a win for gravity not being a force. Thus far.
Everything you're gonna find a way to pull that into every conversation, aren't you? Basically, all it does is it does not confirm extra dimensions, which string theory postulates. The fact that we did not see these black holes by seeing the little particles spray out of the any evaporation of a black hole means that there were not these interactions, means that there were no other dimensions to cause the interactions to occur to elicit a microscopic black hole. So it does not confirm extra dimensions. It doesn't say anything about gravity.
Well, it doesn't. I guess it at least rules out that there's 10 or 11 dimensions. But I think they still have room for your few extras in there.
Okay. Six at least.
It could be 7 or 8 still, I think.
Yeah, maybe. Yeah.
Sure. It was the 10th and 11th that they needed to make this interaction.
Oh dear.
But that did tie into the whole theory of gravitons being able to escape and come back into our universe and travel. It was part of it was tied into the reason for the extra movements and the extra directions of those multiple dimensions was to allow for a very complicated theory of gravity as a particle, and explain
why we don't find the particles anywhere because they're hiding in other dimensions.
Exactly. So
the gravitons, they have this effect, and then they jump into another dimension, and they're like, "Ha! I can't find me."
They would fall off of our brain, go hang out in some other brain for a while, and then zip back when they were needed, and it's more complicated than I can even understand. However, it was part of the reason for the extra dimensions was to allow this freedom of motion for gravitons.
Yeah, well, string theorists need more experiments to push string theory forward. I think I'm excited about the LHC, and in a couple of weeks we'll have one of our predictions shows, and I'm sure that both of us will have some graviton LHC related string theory related predictions. I predict that.
Yeah, I'm predicting. Yeah, I'm claiming. I'm claiming victory on my previous predictions that the LHC wouldn't find a graviton or evidence of
this year.
No, ever. I predicted that they would ever, but I'm going to call victory this year, and if they don't find it next year, I'll claim victory next year. I'll just keep going.
Just keep going until they find it. Yeah.
So they change theories.
Yeah, well, I find it interesting. String theory, I mean, there have been popular books written by physicists related to string theory. There have been TV specials produced on the concept trying to explain this idea of string theory. And now we have the LHC and data starting to come in, and the proof's going to be in the pudding. It's neat. It's really neat to have, the last 10 years have heard people so focused about string theory. It's the unifying theory. It's going to explain, it's going to tie together general relativity with the microscopic universe. It's going to tie everything together. And so far, one experiment here says, meh.
Right. And in one strange way, string theory itself has become such a large-scale model of the universe, down to the nth degree, really, in the quantum universe, even, that string theory will always be with us, and we'll have to stop calling it string anything and just call it theory at some point, because
just theory.
Well, because what it basically is a model of the universe. It's been constructed as a mathematical working model of our universe, and as things get eliminated, actually, like not finding things, which is as significant as if they had found something, actually, because now you put in what you didn't find, and that changes portions of that larger model all the way around. So no matter what is found or isn't found, it adds to this model of the universe that gives us a clearer picture. And there may be some aspects that were assumptions or that looked good, that could work, potential universes, potential ways that the universe could work, that now have been ruled out. and others may come in their place that haven't been disproven yet. And the whole point is to keep being not even, the saying is not even wrong, right?
Yeah.
Not that it's correct, but because it hasn't been disproven, you can put it out there as a not even wrong.
Yeah.
And as you continue,
there's a great book with that title that talks about this.
Absolutely. And so the fun thing isn't that, oh, they were wrong and now the whole theory trashed the whole thing. No, what it means is now we've zeroed in on one of the potential ways that some of the mechanisms of the universe could work. And, well, it doesn't look like it works that way, but we still have these other areas in which it can. And so it's all, you learn this probably in like the 4th or 5th grade, maybe even earlier. It's called guess and check.
Guess and check.
It's a higher level guess and check. It's called string theory, but there is still that element of guess and check in all of science.
Yeah, make a guess and then check it out.
See
if it pans out.
You're wrong. It's like, okay, 2 + 2 wasn't 5. Let's see what else it might be.
Yeah. And on that, what about the atomic weight story that you were talking about earlier? What's happening there?
This is awesome. Okay. So a periodic table has these set atomic weights for all the elements, right? That's one of the key things on there. Well, they've gone through now and decided to finally update 10 of them. And the 10 that are undergoing changes are hydrogen, lithium, boron, carbon, nitrogen, oxygen, silicon, sulfur, chlorine, and thallium. So basically what it is these don't have a specific locked-in atomic weight. They have a range of weights. So really all they're going to do is change that one number that we're used to seeing for the atomic weight of these elements and turn it into a range. And the range will be, almost border up against the other elements in an odd way, because it's like you get up to a certain weight and you can't be this element anymore because you've taken on too much extra baggage, and so now you're this other one. But it's something that has been coming for a long time. Experimenters have known for quite some time. Here's an example. Sulfur has the standard atomic weight of 32.065. However, its actual atomic weight can be anywhere from 32.059 to 32.076. So now we'll get the range of the atomic weights. So all it's going to do is make memorizing that table harder.
Yeah, well, I wonder, it's going to make memorizing the table more difficult, but then, memorizing it is not necessarily where you need to go. It's just knowing how it works that's the most important thing. Why are certain elements put in certain rows or columns or grouped in a particular way? That's the important thing. How do they work together? The atomic weight, though, that's going to be an interesting point in trying to teach why there's a range. Why is the atomic weight different in some situations from others? And I think that's going to be the interesting part of changing the textbooks, because it's implying that, what we've been teaching, this static number, that it's always this way, is wrong, and that we need to change. We have to change the way we look at these elements completely.
There's also some element of, I remember watching something and learning that there was, in the atmosphere, there's heavier hydrogen. I can't remember if it was the heavier hydrogen was near the equator or if that was near the poles. But it was sort of like the separation of hydrogens. And I remember thinking that was odd because I thought all hydrogen was hydrogen. But slight differences, I guess, in the weight. It's sort of like a big salad spinner. As the Earth goes around, it sort of does this slight separation of those.
Like in a salad spinner?
Yeah, I don't know. What is it? What's the thing that the scientists use when they're pulling out the DNA and they put it in the centrifuge? That's the word. So a salad spinner's like a centrifuge. It's the same idea.
Yeah. Yeah, sure. Yeah, I think it's interesting. I think it's very interesting. I think it's going to be challenging. It's going to be challenging educationally in terms of accuracy for chemists and chemists understanding. I don't know. Maybe what we're finding is not necessarily that that just these atomic weights need to have a range, but maybe there needs to be more information somehow, that maybe the periodic table is not sufficient. It's not all elements, only some elements. There are some elements that always stay the same weight, at least as
gold,
fairly
sodium,
far out into their wherever they're found, they're the same. But there are obviously a number, these 10 that they're changing, that differ based on where they're found in nature, and that's okay. How do you you can put a number range, but really, how do you signify that in a table? There's going to be something lacking as we move forward. If this is, a big, with this change, definitely. I don't know.
And it's also kind of fascinating that there would be that there will be different. It's not that they're just variable. Then it's that there's different where they're found in the world. There's sort of a different standard for the element. Yeah. I wonder if that has to do with their development, their history. I wonder if we could be patching back to, back engineering how they came to be where. Mm-hmm. Maybe it's an age thing.
Yeah.
Yeah.
Yeah, exactly.
Who knows?
Yeah, and that's how do you put that in a test? As a chemistry teacher, I think chemistry teachers are just going to continue to use the standard periodic table, even though this change is going to be made.
No, what's great is you can sort of fuzzy remember now.
You
just have to get it in the range. You don't have to remember the specific number. If you can get the number in that range, you're right. It's the correct answer. That's how they should do it.
Awesome. Well, talking about getting into a particular range, Voyager 1. It's out there. It's time for This Week in Space. We got a lot of space news this week. Voyager 1 has reached the end of the solar wind, no longer pushed by the outward motion of the solar wind. It's been heading out for 33 years, and it's just about to head into interstellar space. So exciting! Don't you want to be on that craft? No, you don't. I know you don't.
You know where it is?
The middle of nowhere.
I mean, you can see the stars nicely, but that's about all that's there to see.
Earth is just a little tiny, tiny dot from where Voyager is right now.
Yeah, can it even see us?
Probably.
It must have good eyes.
As a shiny dot.
Are we even a shiny dot?
Wouldn't we be a shiny dot?
I don't even think so. I don't know.
I don't know.
No, because
it'd be pretty cold out there too.
What would we'd be back? We'd be backlit, right?
Yeah.
Except for a little bit of, I don't know, like a half a dot. Even at the best.
Little tiny.
It'd be so.
According to this article sent in by Pamela Taylor, from the Australian Broadcasting Corporation, the spacecraft is now some 17.4 billion kilometers from the sun and has crossed into an area where the velocity of ionized gas, plasma, emanating from the sun has slowed to zero. They suspect that interstellar winds have deflected the solar wind to one side, and the passage through the helio sheath is a major milestone moving forward. What does it say here? So the solar wind travels at a supersonic speed until it crosses a shock wave called the termination shock, and at this point the solar wind slows down and heats up in the helio sheath, which is where Voyager 1 is right now, passing on through that. Very, very cool. 17 billion kilometers, over 17 billion kilometers away. That's a long distance from the sun.
Yeah, but if you're not familiar with kilometers, of course, that would make it 17 trillion meters into space.
All right. Additionally, Saturn, I think it's the Cassini mission, is looking at Saturn, has taken pictures of Titan, which they suspected of having cryovolcanoes, giant ice volcanoes that would spew methane ice, water ice into the atmosphere of Titan and onto the planet, the surface of the planet. The evidence looks as though they might have found them. Yeah, NASA pictures confirm at least one huge possibly dormant volcano, and maybe more. So the pictures make it look as though there's something there. They have an ice volcano that they're calling Sotra Facula. It rises 5,000 feet or 1,500 meters above the surface of Titan in a gently shaped dome, says the discoverer geophysicist Randolph Kirk. This has been seen before in radar and infrared pictures taken by the Cassini probe, but it was this recent pass over Titan that allowed them to actually image this mountain and then be able to determine its size and its shape. It's about 40 miles across. This is a decent sized mountain. 40 miles across, 5,000 feet tall. Says Kirk, I was shocked when I saw the video and suddenly realized what we were looking at. They say there's a computer model revealing two more giant mountains, another with a big crater. The mountains forming a chain several hundred miles long, flanked by lowlands that appear to be enrobed in lava flows. Kirk says that's a combination of features you can't make any way other than by volcanism. It's fascinating. This was all presented at the American Geophysical Union, which is meeting right now, or met this week in San Francisco. So it's just fascinating, the idea that there would be not a volcano spewing lava, but an ice volcano.
But how does that work? Why would the ice erupt?
There are pressures underneath the surface that would push it towards the surface, causing it to erupt. Very possibly, if the crust of Titan is moving and pushing, there's probably water and gas underneath the surface that are not frozen because of the heat of the moon itself and the geological processes that are going on. And so all of those geological processes would take anything that should be icy and actually make it more liquid. That liquid would then get forced by the pressures there, the gases that are building up, get forced out, and it would be an icy spray as it erupted over the surface of the moon.
Wow.
Yeah.
That's pretty awesome.
Yeah. Ice volcano. That would be a cool science project, actually. Just thinking about everybody does 6th grade volcano project. I want to see a cryovolcano science project. That'd be cool. And the question about this is confirming the volcanoes. They've thought there are these volcanoes. They've seen these plumes of ice. If they can confirm the existence of the volcanoes, this is just one more step in the way. I mean, we've talked about this several times of, placing a geologic process that could possibly support life. So if there's liquid water or liquid methane under the surface of Titan, maybe there are processes that there's allowing that allow bacterial life to form under the surface of the moon. Exactly. Star Trek time. And finally, in the Japanese space program, JAXA has sent a spacecraft that was supposed to rendezvous with Venus. I think David Eckerd sent this story, and spacecraft was supposed to rendezvous with Venus, but they missed. The spacecraft called Akatsuki, it didn't enter its planned orbit around Venus. It went around the backside of Venus and ended up in the shadow of Venus. They lost contact with the craft and then were not able to restore contact in time. Didn't have control over the craft as it came out from behind the shadow of the planet. And oops, no orbit. That means...
And you wonder why I don't want to leave the planet.
Everything was growing really great until they didn't do what they were supposed to do.
They went drifting off into the dark of space, and soon everyone aboard was dead.
There's no people on this ship.
People.
No people on this ship. It's not a manned mission to Venus. This is just a craft that's out there. And it's going to get a second chance. This is the great thing. Just has to wait 6 years. Oh, I'm sorry, Japan. JAXA, this is a blow. So sorry.
It happened to poor Hayabusa, too.
Yeah, Hayabusa.
Of course, then again...
We've had our own misses. We've had our own.
It could be job security. Those people at JAXA.
Sweet.
Like,
I have my job in 6 years.
The project's supposed to end in like 8 months, but you can stay all in the on this project for like 6 years if we just like turn off the receiver for a minute.
Yep, exactly.
No, they wouldn't do. No, they wouldn't do that. But it is a difficult thing on these long-term projects to keep all that information going, keep people in the know who are still on board with one of these projects. I mean, Voyager's taken off, the Pioneer projects. A lot of the data that was sent back hasn't even been looked at. There's not even people who are working on processing parts of it because there's still some data streams that have been coming in, but it's not as interesting as what we can see and what we can capture now anyway. Or, other means because of the technology changes. But yeah, I hope somebody's got it turned on and in their eyes and ears looking for it in 6 years.
Yeah, I'm sure they will be. I don't think they're going to give up on it. They'll put it on, tracking. They'll check in on it every few months, make sure it's doing what it's supposed to do. Some grad student will probably have to man the controls. At some point it'll be, they'll do something with it. 6 years from now, so 2016 or 17 is when we can expect to hear
the
more.
Next update.
Yeah. So unfortunately, this means no cool updates about Venus through JAXA for the next little while. So we're Venus blind for a while. We are. Is it time to take a break?
Yeah, it could be.
Yeah.
I'm gonna go work on my ice volcano project.
Okay, awesome. You get
During
on
the
that.
show, I got texted. My son no longer wants his school science project to be a self-propelled single occupancy hovercraft. He now wants to do the ice volcano thing. Thank you very much, Kirsten.
You're welcome.
For
You're welcome.
giving me another project.
Anytime. I just try and keep you busy. That's all. I try and help. I know you love being busy. So stay tuned, everybody. We'll be back in just a few moments. This is This Week in Science. We have more science news, a big filled second half coming at you. Stay tuned.
Can't explain the things you heard with more than intuition. The line of reason shows the way to go. No conclusion. The methods of hypothesis and patience are the only things I read.
And what did I do with the ad? There it is. Like audiobooks? If so, you can get yourself a free one. Audible.com is the leading provider of audiobooks with over 75,000 different titles in a variety of different genres. You know, we love the science. They have a lot of that. You can find all sorts of science books in the Audible library. We've found many books there in the past, and we've read them, we've listened to them, and we have enjoyed them. At least I have. You can start a free trial today. If you get and with your free trial, you can get any audiobook download you want for free. One audiobook download for free, and all you have to do is sign up. Sign up at audiblepodcast.com/twis. Go to audiblepodcast.com/twis right now for your free download. And read Apocalypse, Earthquakes, Archaeology, and the Wrath of God by Amos Noor with the Twis Book Club. That's what we're reading this month. December's book of the month. You know, it's Twistmas time, so, why not talk about global destruction? Yeah, sure. Sounds great. Anyway, Earthquakes, Archaeology, and the Wrath of God by Amos Noor. That's what the Twis Book Club is into this month. Great read. I've already started it. Really interesting ideas by a very bright scientist. Head on over to Twis, TWIS.org to get your copy and join in the conversation about the book, a thought-provoking book that pits earthquakes against society and culture. Too much fun. Too much fun.
Lie somewhere within this scattered plot. Our first assumptions were correct. Disprove the rest. It's our methods and hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
And we're back with more of This Week in Science.
That's right. We have more. More. This Week in Science is so filled with sciencey goodness. What you got, Justin?
Ecstasy.
What? Are you a drug dealer now, or are you just really happy?
Drug that gives you those love feelings.
Yes. What about it?
MDMA, or ecstasy, as it's known on the street, increases feelings of empathy and social connection between people. These empathetic effects suggest that MDMA might be useful to enhance the psychotherapy of people who struggle to feel connected to others, as may occur in association with autism, schizophrenia, antisocial personality disorders. This is, even though this is a news story, this is actually why this drug was developed in the first place. It was used in the beginning solely for clinical therapies, psychotherapy sessions. It was used, actually, I think it was primarily used for couples therapy. But
Yeah, I think
this was the path that was already down many, many years ago, until it became the Austin socialite drug of choice.
Yeah.
And people began enjoying it for,
Other reasons. Yeah,
recreational psychotherapy, as I would call it.
Okay, recreational psychotherapy. Yeah, the idea originally was that you could that couples therapists they'd give the couples these a dose of the drug. It would make them more emotive, able to talk about their problems. So if you have a couple who's having communication problems, suddenly they are able to talk about their feelings a little bit more, maybe able to feel like they're connecting more deeply with one another. And that was what it came out of.
Right. It worked much better than giving couples. It worked much better than giving couples truth serum. And those sessions ended badly for some reason.
Yeah, I wonder why.
Dr. Glinda Beatty, author, explained, "We found that MDMA produced friendliness, playfulness, and loving feelings, even when it was administered to people in a laboratory with little social contact. We also found that it reduced volunteers' capacity to recognize facial expressions of fear in other people, an effect that may be involved with the increased sociability said to be produced by MDMA. So you can't tell us this story you're telling is creeping people out. So you keep going. I don't know. It suggests that it it produces effect that make others seem more attractive and friendly, which may serve as a significant motivator in its use as a recreational drug, but also it makes others appear less threatening, which could increase users' social risk-taking. Those are all the disclaimers there. But within the context of treatment, these effects may promote intimacy among people who have difficulty feeling close to others. However, it does distort one's perception of others rather than producing true empathy. But I guess the idea is in using it in somebody who has the sort of blockade to social interaction and connection with others, simulating the feeling, because it would be simulated. There's a drug causing this in your brain that also is debatable whether or not you always have drugs causing things to happen in your brain sober normally without narcotics, because the brain is in a sense a sort of a drug regulator Yeah,
absolutely. You have a certain amount of, in your normal day, you have a certain amount of neurotransmitters that get released for various reasons. You know, you drink caffeine, you're going to have, different neurotransmitters that are released. You're going to feel more up and excited. You have a big meal, you're going to have a number of other neurotransmitters released that'll make you feel kind of sleepy and satiated.
Things that simulate there are basically a form of morphine that you have morphine.
We have opiate compounds.
Opiates in your brain that deliver the junk. If you do
that's
what
not
the
the
brain
only.
wants
But that's
you to
not
do.
the only. That's not the only thing. Not all of these neurotransmitters are opiates. But we take compounds. So like ecstasy. Ecstasy is a drug. The methyl diethyl methamphetamine. It gets into your brain and stimulates receptors that block the reuptake of serotonin, so that, or it causes a dumping of serotonin. I can't remember specifically what it is, but you end up with more of a certain type of neurotransmitter, serotonin, in your system than you normally would. And it's like it causes a really mass dumping of it, which is even more so than would be caused by eating food or doing other things that would normally cause the dump of serotonin into your system. So, it's the question of, you do these things on a normal everyday basis, and you have these neurotransmitters released and everything's regulated. You can eat things or do things that will change the way that they're released. But then you take a drug and it like substantially changes it. So, it's all levels of degrees,
Right.
in how it works. But anyway.
Right. But I suppose then the idea of this therapy, though, using the drug using ecstasy as a therapeutic situation for somebody who is maybe autistic, maybe schizophrenic, or somebody who lacks the ability to have real empathy, if it can induce this, it won't be a lasting effect. But if there's an awareness of what empathy feels like,
right,
perhaps. Or it may be something that can awaken those channels in some way. It's something worth looking into, and it is sad that the fear of the recreational drug has put us in a situation where therapeutic usages of drugs are equally illegal.
Yeah, I absolutely agree.
They need to fix that law, and I'm not talking like getting a medical ecstasy card. Hey,
right.
Doc, I lack empathy.
But in a clinical setting where it's regulated, where you have doctors present who can monitor it, make sure that everything's done safely, why not? Yeah, why not test the effects in these different situations? And I think you're right. If you can create awareness of empathy in individuals who can't normally experience it, that would be pretty cool. I mean, the question is, do we know if we give them these drugs, will they experience it? Do they have the neurological capability? Like, are the mechanisms in place, or is the reason that they can't feel empathy that they don't have the mechanisms? So we have to find out between different types of disorders, what's at play? What is the disorder down at the structural level? Is it a fact that they release serotonin, but then don't have receptors to pick it up, which would mean that if you took ecstasy, nothing would happen because your brain would be flooded with it, but not have anything to do with it. Right. There are just all sorts of really interesting effects that we don't even know. And the drug culture and the war on drugs just completely stops that kind of research from happening to find out more.
It may be a little bit of self-preservation for some of politics.
Of course.
To, especially harkening back to last week's study that indicated that people who tend to be conservative may also tend to be less empathetic. We may have found a medical cure for ultra-conservative.
More ecstasy.
Hey, what? There's
ecstasy
a budget
for
impasse?
everyone.
I know, we can solve it. Yeah, I can get everybody to the table together. Don't worry. I figured it out.
Too funny. Oh my goodness. Study, this was sent in by Gord McLeod. He sent in this really interesting future of world robot domination, maybe even closer. We have now gone from monkeys who can control external robotic devices through neural inputs to they're developing this technology even further, trying to get it even better. The researchers at the University of Chicago, they published a study in the Journal of Neuroscience in which they included sensory feedback in the system. They found that monkeys that were being trained to use just their mind, the power of their minds to control a robot or a robotic arm, picked it up much faster if they had some kind of sensory feedback. So what they did is they stuck the arm of the monkeys in a device that bent the monkey's arm as the monkey was thinking about bending the robotic arm and having the robotic arm do something. So it gave a certain amount of sensory feedback from this sleeve that the monkey's arm was in that allowed the monkey to figure things out a little bit better and to learn how to use the robot even better. What they're saying is that if they can create these enhanced type of brain-controlled interfaces, BCIs, if they can create some that are enhanced, that allow for sensory feedback in some way, that your brain will figure things out a little better, make it a more natural device to wear and to use, and then this could lead to exoskeleton robots that we could wear. Says the author of the study, wearable exoskeletal robots could provide sensory information to patients with full or partial feeling. Alternatively, direct stimulation of the relevant area of the cortex, the part of the brain, could be used to replicate sensory feedback in patients who have lost both motor and sensory function. So if they've lost motor and sensory function, but you can get them to start learning how to use a robotic device, you can give that feedback to the appropriate part of the brain. So if they're paralyzed and they don't feel it externally, that you could even, stimulate the part of the sensory cortex that's attached to, or the motor cortex that would normally be stimulated by movement, and just do it all in the brain. Kind of exciting. Very interesting movement forward. This research was supported by the National Institute of Neurological Disorders and Stroke and the Paralyzed Veterans of America Research Foundation. So there are definitely a lot of people who are interested in seeing this come out into the future. Wearable exoskeletons. Awesome.
Well, and in a sort of analogy, analogous sense, we already sort of have that in our automobiles. The vehicle that you drive very much becomes an exoskeleton, and you sort of begin to feel and sense this extra body around you.
Yeah.
Prime example of that is I had the 66 Ford Thunderbird. Huge monster of a vehicle, right? I went from that to a little Toyota Corolla. Tiny, small, subcompact. Went from larger, one of the largest vehicles ever made to a nice, small subcompact. Now, when I would park the Toyota, when I first got it, I would be working my way into a tight parallel parking spot. And then I'd get out and I would look and there'd be 4 feet in front of the car, 4 feet behind it, and I'd be 3 feet from the curb. Because I'd been driving that larger vehicle for so long that my sense of where everything was, where my exoskeleton should be, was still in that old body.
Right. Bigger.
Right. So, yeah, I mean, I think the brain has the ability, certainly, to encompass an exoskeleton. It's ready for it. It's looking for more limbs.
Absolutely.
it's ready to add them. It's got plenty of input slots. Some limb USB slots all over the place. We just have to figure out how to get them integrated.
Yeah, I totally agree. Totally agree. What you got?
New study suggests that not eating almonds will give you type 2
almonds?
Almonds.
Almonds?
Almonds.
Okay.
They're almonds once they're off the tree.
I'll take
when
your
they're
word
on the
on
tree,
it.
they're almonds.
Oh, really?
Yeah. And then they shake the L out of them. And that's how they get them down on the ground. And then you have almonds. Come on, you're from the Central Valley.
Oh, dear. Yeah, I know how it works. All right,
Not eating almonds will give you type 2 diabetes and heart disease. So you need to start eating your almonds. With nearly 16 million Americans pre-diagnosed with prediabetes, a condition that is the precursor to type 2 diabetes, and half of all Americans expected to have either prediabetes or type 2 diabetes by the year 2020. Nutritional approaches to maintaining healthy blood sugar levels is kind of an important thing, maybe. The findings of this scientific study examining the health promotion and disease prevention benefits of almond consumption were published this June 2010 Journal of American College of Nutrition. The study, one of the first of its kind to quantify prevention data, illustrates that consuming an almond-enriched diet may help improve insulin sensitivity and decrease LDL cholesterol levels in those with the prediabetes. So what they did was they basically had this group that consumed the ADA recommended diet with 20% of their calories coming from almonds. And that group on the almond-enriched diet showed greater improvement in insulin, homeostasis model analysis for insulin resistance, homeostasis model analysis for beta cell function, and clinically significant reductions in LDL cholesterol as compared to the nut-free people. This is good news because there's lots of, in fact, look at this. There's almonds everywhere. And they're
Those
so
look like
good.
almonds to me.
It's a silent L.
Okay. I think it's interesting. I mean, 20% of your total calories from almonds that's substantial. That's a fifth of your daily diet.
So lots of fiber, unsaturated fat.
I love almonds. I'm not gonna snub my nose at eating almonds, but that's a lot of almonds to eat every day. But that's a substantial effect as well. Good for these people who are, I guess, at risk for diabetes.
Mm-hmm. Yeah. I think it's for the cholesterol too. There's people running around trying to get the reduction in the LDL cholesterol. So, cardiovascular disease too. It's a superfood. Put it in your diet.
What I think is interesting, something here, it says that although study participants in both groups were instructed to consume the same amount of calories from carbohydrates, there was less self-reported carbohydrate intake among those in the almond group.
Right.
And I wonder if that's, what that is a result of, why they would eat fewer carbohydrates. Is it, very often, if you eat carbohydrates are sugars. The idea is that if you eat carbohydrates beget eating more carbohydrates because you burn the sugars up pretty fast, and so you stay you're hungrier more often. But with almonds, if they're fiber rich and if they have more complex sugars to them, that's very, very possible that they could be satisfying, satiating hunger and making people a little less hungry and more feel less like they need sugar or the carbohydrate power source.
Right, and almonds are pretty heavy, too. So maybe it's you don't feel like taking on the pasta or what have you.
Right. I wonder how many. I just want to know how many almonds that is every day.
I don't know. Almonds. I don't know what the recommended. You know what? Maybe it's 20%, on the bag. 20%
of your. No, but it's 20% of your, for these dieters. 20% of their daily calories. So whatever the diet they put them on.
There's about 10 calories, less, a little more than 10 calories per. Oh no, that's servings per container. Serving size is a quarter a cup. A quarter a cup has 170 calories. What is the daily intake? It's around 2,000 calories, something like that? 1,500
to 2,000, depending on, maybe more depending on your height, how big you are.
So it's like a half a cup of almonds. You got me saying almonds now.
Ha ha! Gotcha. Yeah, okay.
One disclaimer, though.
Half a cup of almonds a day.
One disclaimer. That's a lot of protein.
Yeah.
Make sure you're doing like some heavy crunches, some hardcore yoga, maybe a little weightlifting, some push-ups. You want to exercise so that protein has work to do. Because if the proteins don't have work to do, that half a cup of almonds is going to turn into night toots.
Okay. Disclaimer.
I didn't experiment.
Another piece of news that was reported this week at the American Geophysical Union meeting here in San Francisco. It's a paper that's going to appear in Earth and Planetary Science Letters. Researchers are trying to take a look at our magnetic field throughout history. How do you measure the past of our magnetic field and changes in the magnetic field over time? Usually what researchers do is they use iron. So molten or melted iron, it'll from inside the Earth's inside the core of the Earth or under the crust will shot out in lava. You'll get iron that cools at the surface of the planet. And when it cools, that iron, the particles in the iron are affected as it cools by the magnetic field of the Earth. So the magnetic field will trap those particles in a particular orientation based on the orientation of the magnetic field. And so they've looked at the paleomagnetists, they call themselves, those who study the history of the Earth's magnetic field, have been looking at the iron in various rocks found in different places, different depths that can be dated to certain times in the planet's history. Found that normally the thought is that changes in the magnetic field are small and really slow. And the number is that they fluctuate by about 16% over 100 years. So not much change over a period of time. However, there's a new study in Israel, southern Israel, where researchers are using a different process. They're looking at slag or copper from a mine. And the researchers who are working on it say that the ancient Egyptians melted ore to produce copper. They had a lot of leftover molten rock. They threw it on a waste heap, and that rock cooled quickly and left a signature of the magnetic field. And so the researcher says it's like a small-scale lava flow. So they looked at what the magnetic field was doing about 3,000 years ago, which is about the time that the Earth's magnetic field last peaked. They looked at that time period, looked in the slag from these copper mines, and they found that there were these abrupt spikes that occurred very quickly. And both times the field jumped up in strength and fell by at least 40% in the space of about 20 years. So a massive change in the magnetic field strength during these periods of time when the Egyptians were mining copper. Another researcher says that who's not involved in the study says they see the fields changing 5 to 10 times faster than anything else we have seen so far. So the question is, why or how would that be happening? What they think is that the spikes are maybe local changes in the magnetic field, and what possibly could have been happening, that even though globally the magnetic field wasn't changing very rapidly or dramatically, that possibly in these very localized regions, if researchers start looking in very small pockets and localized spaces, they might find these kinds of spikes that are much more dramatic, and that could be explained, that, I don't know how they'd prove this, but could be explained by saying a huge chunk of iron in the Earth's core passing very rapidly underneath that point in the crust and causing a dramatic change by affecting the magnetic field in that area as it passes by. Yeah. So anyway, this is an interesting way, a new way using slag from human activities to be able to try and look at changes in the magnetic field. And so they're going to try and the researchers are going to go to Roman mines in Cyprus and see if anything similar has happened in that area. See if there were any kind of spikes around the same time period. Kind of interesting. How is our planet changed through time, and how can we figure that out? I love questions like that. This is from an article in Wired Science written by Lisa Grossman. Do you have anything else?
I'm just noticing how much taller I am than you.
Why are you sitting up so tall?
So I don't look like I have a giant head. Hey, next time you're at work and you're watching that kitten change channels on the remote, or whatever YouTube viral video is making you laugh, get a copy of this article right here. It's in the Association for Psychological Science. It says people who watch funny videos on the internet at work aren't necessarily wasting time. They may be taking advantage of the latest psychological science, putting themselves in a good mood so they can think more creatively. Generally, positive mood has been found to enhance creative problem solving and flexible yet careful thinking, says Ruby Nadler, a graduate student at the University of Western Ontario. She and colleagues Rahi Rabi and John Paul Minda carried out a new study published in Psychological Science, a journal of the Association of Psychological Science. For the study, Nadler and her colleagues looked at particular kinds of learning, and that is improved by creative thinking. Students that took part in the study were put into different moods and then given a category learning task to do. They learned to classify sets of pictures with visually complex patterns. Researchers manipulated mood with the help of music clips, video clips. First, they tried several out to find what made people the happiest or what was the most depressing. Happiest music was a peppy Mozart piece. The happiest video was that of a laughing baby. It's hard to You see laughing babies. It's hard not to smile. Researchers then used these in the experiment along with a sad music video, Schindler's List, and then a news report about an earthquake that presumably killed people. Piece of music and a video, as well as a piece of music and a video that didn't affect mood at all. After listening to the music, watching the video, people then had to try to learn and recognize a pattern. The happy volunteers were better at learning. Wow, they were better at learning a rule to classify the patterns than the sad or neutral people. If you have a project where you want everyone to think innovatively, or you have a problem to carefully consider, being in a positive mood can help you do that, says Nadler. And music is an easy way to get you in a good mood. However, everyone has a different type of music that works for them, so you don't have to listen to Mozart and Laughing Babies, but of course, in this experiment, that worked. So yeah, next time if you get caught, this is like if you get caught by your boss watching some sort of dancing baby video or what have you, or dancing dog. Dancing dog is making me laugh, and now I am ready to finish my book.
Now you're ready to learn. You're ready to learn.
To go take on a project or two.
That's right.
Dancing dog, he goes on forever. How can he do it? He's got so much energy, that dancing dog.
I just wonder, what is music that has no emotional effect? What kind of music doesn't affect mood in any way? I mean, is it just a pure tone of sound? But then that would be kind of like a mosquito, and that would bug me. What kind of music is going to have absolutely no effect on somebody's mood?
I don't know. That's kind of a good question.
I mean,
everything.
Yeah.
Music?
Right.
Just some sort of boring backgroundy music? Mall music? See, now I'm all right. Yeah, okay.
Yeah. Yeah, I don't know. I have no idea. I wonder. Alex looks ready to cue something up here. He looked ready. I had one final story. There's a news headline that's been out a little bit about a cure for HIV.
Yay! They cured it! Woo!
Not really. Maybe. I don't know. It's very, very, very preliminary. That's why nobody's really, it's there. People are talking about it, but it's not really out there. So, anyway, I just want people to think about this story before they get excited about the potential HIV cure. Paper in the journal Blood documents a trial in which a guy, an AIDS sufferer, Timothy Ray Brown, had developed myeloid leukemia, which is cancer of the immune system. They treated him with chemotherapy to suppress the cancer, and then they gave him a bone marrow transplant with stem cells from a matched donor. However, the matched donor, the stem cells that they used had a mutation in a gene called CCR5 that is known to confer resistance to HIV in about 1% of the population. So basically, the doctors went out and they looked for a donor who would match their patient who also had this CCR5 mutation. They transplanted. The transplant seemed to go well, which is also, very difficult because you basically have to destroy somebody's immune system to transplant, give them an immune transplant to begin with. But they followed him for a few years, and he has stayed AIDS free. He seems to be not progressing in any way for like the last 3 years. 3 years. So, we don't know if this is going to last for a really long time. This is only one individual. So the question is, is what do we know other than, okay, it worked in this one person? We don't know much. So more research definitely needs to be done. This is not something that we can consider a cure at this point in time. And even if it did work for this one guy, it's a serious procedure to go through this kind of a transplant. So it's not necessarily the kind of cure that most everyone would be able to jump at and get excited about. So just, I hate to be Debbie Downer, but I like, science with a grain of salt. I know.
Well, for next week's show, I do have I think it was from Live Science. Oh gosh, I'm not sure where it's from now. I'll give it the proper props next week. But the top 10. So we put together a top 10 list of retracted science headlines.
Oh, cool.
Yeah.
That'll be fun. That'll be great. Yeah.
So I'll
Can't
bring
wait.
that for next week. Also, the lost city of Neanderthals.
Yes.
We're gonna do that one next week Monday. I guess we're gonna. Are we doing it live here with the video and the thing?
Yeah.
Okay, so Monday, a special Monday double show
That's right.
because we won't be here next Thursday. Is that right?
That's right. Yeah, we have a double header next Monday because it's heading into the holidays next Thursday. And yeah, so we need to line up some shows ahead of time. It'll be fun. We'll have 2 hours of Twis, 2 shows in a row. We're going to be recording one regular show, and we're going to be recording our Twismas show.
Is it the Twistmas show?
The Twismas show is also our 300th episode.
Wow. Well, that's awesome.
Yeah. It'll be our 300th episode. It'll be our Twismas episode. So that'll be our second show next Monday night. And I believe the plan is to start at 7 next Monday night. But there's no other shows on, so we can talk with these people to see if there's rescheduling that needs to happen.
Yeah. I'll know for sure whether or not I can be here then at about 7 o'clock.
Okay, great. Okay, Mr. Planner. Also, I'd love to get your ideas for the top 11 science stories of 2010. We're going to be doing our rundown of the top 11 stories of the year. We do this every single year, and I'd love to get your input. So we're calling out to you people. Send us your favorites. We're going to tally up the votes, report the winners in our annual end of the year rundown show. Email me, Kirsten at thisweekinscience.com, and use the subject Twis Top 11 of 2010 so that I can see the stories you really, really got excited about this year. What were the big ones? And thanks, everyone. Shout outs to Ed Dyer for all the great stories this week. David Eckerd, Pamela Taylor. Who else did we have? Richard Barton, Gord McLeod, Ryan Dunning. There's so many great stories from Monkey, Tony Steele.
Logan Waterman. I don't know if I did one of his stories or if that's one of the ones I've got filed for next week. He was in here too.
So many great stories. Thank you, everyone, for sending them in. Always appreciate them.
Oh!
Once again.
Somewhere I had...
Did you throw all your papers away somewhere?
There was another document I had. Has words on it that I need to say right now. I need to be... Those are the words. Thank you, everyone, for listening. How could I forget? We hope that you enjoyed the show. Twist is also available via podcast. Just search for This Week in Science in the iTunes directory. If you have an Android device, you can look for the Twist for Droid app in the Android marketplace.
Oh, yeah, I'm supposed to say something now. I was reading the chat room. Make sure you, for the 4, it's the number 4, not spelled out. Twist number 4. Or droid. For more information on anything you've heard here today, show notes will be available on our website, www.twis.org. We also want to hear from you, so email us at Kirsten@thisweekinscience.com or Justin@thisweekinscience.com.
You can also contact us on Twitter at Dr. Kiki or at Jacksonfly. Oh, if you send us an email, put Twis, TWIS, in the subject line, or you will be spam filtered into oblivion. We do want your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, an insider stock tip, a science story that you want to leak ahead of its do not leak this date, please let us know.
Yeah, and we'll be back here next week. And we hope that you'll join us again for more amazing, great, fantastic, super califragilisticexpialidocious science news.
And if you have learned anything from today's show, remember,
it's all in your head.
I've got the kind of mind I can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Oh, I'm going to break things. Trying to swing the fez around. This is not my fez, but I have a fez of my own now. It makes me very excited.
We all have fezzes of our own now.
We do. Everyone
is way too small.
probably fit better than this one.